Hey guys, Mr. Backerberg here. In this video, we're going to look at right triangle trigonometry. So let's take a look at this triangle that we've got on the right-hand side of our screen. Now we know that it's a right triangle because we've got that right angle box in the corner. And what I'm going to do is, in this bottom left-hand corner, I'm going to put my angle theta. When we're dealing with trig functions, we want to be focused on a specific angle. Now, back in geometry, we defined our basic trig functions using the sides of a right triangle. Now, as we're taking a look at our right triangle, the side that's across from the right angle is the hypotenuse. If we're focusing on this theta angle, then directly across the triangle from theta is our opposite side. And then the side that's right next to our angle theta, not the hypotenuse, but the other side, is our adjacent side. Now, when we defined our basic trig functions, we talked about the sine of theta, the cosine of theta, and the tangent of theta, and we looked at setting up a ratio, a fraction, using sides of our triangle. And the sine is the opposite side over the hypotenuse. The cosine is the adjacent side over the hypotenuse, and the tangent is the opposite over the adjacent. But there are a few other trig functions that are related to these basic trig functions. And what they end up being is the reciprocal of these three original trig functions that we've dealt with. The reciprocal of the sine is called the cosecant, which we abbreviate as CSC. So the cosecant of our angle theta, we said it's the reciprocal of the sine, so that would be the hypotenuse over the opposite. The reciprocal of a cosine is a secant, which we abbreviate SEC. So the secant of theta would be the hypotenuse over the adjacent. And the reciprocal of the tangent is the cotangent, abbreviated COT. So the cotangent of theta would be the adjacent side over the opposite. So let's say we're taking a look at this triangle, and I'm going to label the sides. I'm going to call this short side across the bottom 3. This vertical side is going to be 4, and our hypotenuse length will be 5. That's a pretty well-known right triangle, and I'm going to throw my theta angle down in the bottom left-hand corner. Now, if I want to find the sine of my angle theta, we said earlier that the sine was the opposite side over the hypotenuse. So opposite of the theta is the length of 4, and my hypotenuse is 5. If I wanted to do the cosine of theta, we know that the cosine is the adjacent over the hypotenuse, so I would go 3 over 5. And if I wanted to find the tangent of my angle theta, tangent is opposite over adjacent, so that would be 4 over 3. Now I can also find these reciprocal trig functions as well. So if I wanted to find the cosecant of theta, cosecant is the reciprocal of the sine, so it's hypotenuse over opposite, so that would be 5 over 4. I could find the secant of angle theta. The secant is the reciprocal of the cosine, so it's the hypotenuse over the adjacent, so that would be 5 over 3. And then I could also find the cotangent of angle theta, and the cotangent is the reciprocal of the tangent, so that would be adjacent over opposite, so that's going to be 3 over 4. So we can set up all 6 of these trig ratios based on looking at this angle theta within our triangle. So in this example, what we're going to do is we're going to be given one trig ratio, and we want to use that to help us find all of our other trig ratios. So let's say that we're told that the sine of angle theta is 5 over 6. Now the first thing I would do is draw myself a picture of this triangle. So we've got our angle theta in here. Now sine gives us the opposite side and the hypotenuse. So I know this side across from my theta has to be 5, and the hypotenuse across from my right angle needs to be 6. Now, in order to set up my other trig ratios, I need to find this missing side. Because we're dealing with a right triangle, we can use the Pythagorean theorem to help us out. So I'm going to label this other side as x. So then what I would do is I would take x squared plus 5 squared equals 6 squared. So we'd get x squared plus 25 equals 36. I would subtract the 25 over to the right-hand side, so I would get x squared equals 11, but then I have to square root both sides in order to get rid of the squared. Now, typically, as we're square rooting things, we worry about a positive answer and a negative answer. But because we're talking about an actual length within this triangle, we can't have negative lengths, so we're only going to be concerned about the positive square root in here. So that's going to be the square root of 11. So this missing x side right here is the square root of 11. Now I should be able to use this triangle now to set up the rest of my trig ratios. So then the cosine of theta would be the adjacent side, which is at root 11, over the hypotenuse of 6. The tangent is going to be the opposite side over the adjacent side. So we would have 5 over the square root of 11, but we don't typically like to leave radicals on the bottom of a fraction, so I'm going to rationalize this denominator by multiplying top and bottom by that square root of 11, so I really end up getting 5 root 11 over 11. Now, as far as the cosecant goes, I'm going to take that sine and do the reciprocal of it, so hypotenuse over opposite, we get 6 over 5. For the secant, we need to do the reciprocal of the cosine, so that's going to be 6 over the square root of 11. But again, we don't like to leave radicals on the bottom, so if we rationalize this, we should get 6 root 11 over 11. And then for our cotangent, we're going to do the reciprocal of the tangent, so the adjacent side over the opposite side, so we get root 11 over 5. That's going to be it for this video. Thanks for watching.